In this video, we will review how buoyant forces work on stationary objects or objects that aren't moving up or down. So if we've got this object that's just floating in some kind of water and the object isn't moving up or down, then we know that the pressure that's keeping this moving up is going to be the same as the pressure that's pushing it down. If we want to write this as a math equation, we could say P up equals P down. Now, we know in general the equation for pressure is equal to some force over an area. And in this case, the pressure we're talking about is the pressure going down. So we're going to call it sub D, or pressure going down. And we know that's equal to the force over the area. We can rearrange this to solve for the force by multiplying both sides by an area, and then we'll end up getting the force is equal to this pressure times some area. Now we also know that if the object isn't moving up or down, then the pressure is going to be a static pressure, not a dynamic pressure, because no movement's happening. And the equation for static pressure is equal to rho, which is the density, times gravity, times whatever height it is being suspended from. And so if we were to substitute rho GH instead of the pressure into that force equation, we could then say the force going downward is equal to rho GH times this area. Now, we also know that height times an area is equal to a volume. And so instead of saying rho GH times A for the force downward, we could also say the downward force is equal to the rho G didn't go anywhere, but now instead of saying HA, we can say V. And again, because we know that this object is suspended, the force going down is going to be the same as the force going up. And so then we could also say the force up, or the buoyant force in this case, which is the force that's pushing it up, is also equal to rho G V. That's one equation we have for the buoyant force. But at the same time, we know that this downward force is also equal to mass times gravity. And so because those are equal to one another, we could also say the buoyant force is equal to the mass times gravity. And either one of these equations could be used to figure out the buoyant force depending on which you have. Obviously, you're going to be given G, but are you given the density and a volume, or are you given a mass?